Hi, good morning. Welcome to Electronic Devices course. Okay, we are going to next few minutes. We are going to study new concepts. What is the electronic device? What are the latest modification, technology innovations are there, and basic concepts. Okay, are you ready for this? Okay. Okay. Before going to this, we will say the what is the course overview of these electronic devices. Okay, in the first unit, we are going to study what are the PN junction diodes and what are the basic characteristics of PA characteristic that is called as volt current, volt ampere characteristics, ideal versus practical diode, static and dynamic resistance, breakdown mechanisms, and Zener diode characteristics. Okay, these are the subtopics in the unit 1. Next, in the unit 2, we are going to study what are the various rectifiers. Okay, these rectifiers we are using the mobile chargers. Okay, all the electronic devices are based on they are designed based on the rectifiers. Okay, we are going to study what are the various rectifiers: half wave rectifier, full wave rectifier, bridge rectifier, and various filters and voltage regulators. In the third unit, we are going to study by BJT, that is called as bipolar junction transistor. Okay, here we are going to observe what are the various input and output characteristics, that is common base, that is called CB, common emitter CE, and common collector CC configuration. Various input and output characteristics we are going to observe, and what is the biasing and what is operating point. These are the subtopics in the unit 3. Next, in the unit 4, we are going to study junction field effect transistor, that is called as JFET. What is the internal construction, operation, and characteristics of JFET, that is called drain and transfer characteristics, MOSFETs, and its characteristics we are going to study. Next, in the unit 5, we are going to study what are the various oscillators. Okay, RC phase shift oscillator, that is called resistor, capacitor, RC phase shift oscillator, LC, inductor and capacitor based oscillators, Hartley, Colpitts, and crystal oscillators. Okay. Next, the course outcomes. After studying all these 5 units, students can able to achieve. These are the course outcomes: to understand the various operations of the characteristics of electronic devices, and design of a rectifier and full wave rectifiers with filter and without filter. Able to design and characterize the various current flow of BJT, that is CBCE, CC input and output characteristics, biasing of the transistors, and they can able to analyze the FET characteristics and MOSFET characteristics, metal oxide, semiconductor, field effect transistors. Okay, next, able to design and analyze the various oscillators, that is RC phase shift, LC oscillators, and crystal oscillators. Okay, first we'll observe brief history of the modern electronics. Okay, what are the various innovations in the technology upgrades from the last 50 years? Okay, first the device is introduced as diode in 1940. Okay, before 1940 we are having very big radios and televisions. Okay, before diode we are having vacuum tubes. Okay, this is invented by Russell Hall, the scientist names. Next we are after diodes, again they are combined these diodes and they are manufactured BJT, that is in 1947. Invention of transistor, that is, these are the 3 scientists names. Next, in 1950, IC is introduced, that is called as integrated circuit. Okay, combining BJT and diodes, other small elements, IC is fabricated, that is called in the year 1958. Next, in the 1963, CMOS logic gates are introduced. Next, in the 1970, the first microprocessor is introduced, that is Intel 4004. Next, in 1978, first VLSI chip is fabricated. Okay, these are the various classifications of the technologies, innovations from past 50 years. Okay, VLSI chip consists of more than 10 power 5 transistor in one chip. Okay, these are the basic electronic components we are going to study. So in the unit 1, first we are having p-n junction diode and its functionalities. Okay, before going to study, first you have to recollect all the informations of atomic structures. Okay, atom consists of nucleus and electrons. Okay, nucleus is positively charged protons and neutrons. Electrons are negatively charged. Okay, these are the what is valence electrons. Okay, just to recollect basic concepts so you are studied in inter and physics. Okay, these are the various elements of semiconductors. Okay, more popularly used is silicon and germanium. These are the semiconductor materials. All the transistors or devices, electronic devices are fabricated by silicon and germanium. Okay, this is a silicon atom diagram at 0 degree Kelvins. Okay, you're having semiconductors are classified into two types, that is intrinsic and extrinsic semiconductor. Intrinsic is pure semiconductor, extrinsic is unpure semiconductors. Okay, you're having insulators, conductors in semiconductors. Okay, conductors are the more free conductor is allows the free of electrons. More conduction is possible in conductors. Insulators, there will be opposition, they are protecting the electricity, so there is no flow of current in the insulators. Okay, next semiconductors, the energy band gap is in the order of 1 electron volt in the semiconductor. Okay, these are the movement of holes and movement of electrons. Semiconductor constants, this is intrinsic carrier concentration of free electrons, and these are the various semiconductor constants. Silicon having 1.1 electron volt, okay, and gallium arsenide is having 1.4 electron volt, whereas germanium having 0.66 electron volt. Okay, extrinsic semiconductor, that is unpure semiconductor. This process adding some impurities called as doping process. Okay, you're adding semiconductor some doping element, that is trivalent or pentavalent impurities to get n-type or p-type semiconductors. Okay, you're having donor and acceptor impurities. Okay, to get n-type semiconductor, we are adding pentavalent impurities. Okay, this is called as PAAB. In shortcut, we are calling as PAAB, that is phosphorus, arsenic, antimony, bismuth. These are the elements. Any one of the element is added to the pure semiconductor, we can get the n-type semiconductor. Next, we are having p-type semiconductor. This is you can get by adding trivalent impurities. Okay, they are called as BAGA: boron, aluminum, gallium, indium. By adding this any one of this material, you can get p-type semiconductor. Okay, these are the various applications of the electronic device. We are having so many applications in the communication. Presently, everyone is using mobile phones. So communications, we are having so many other applications: mobile communication, satellite communication, radar communications, navigation communications, and other so many applications are there in the communication area. Next, we are having defense applications for missile launching, other applications, and automotive, that is cars, smart cars, all applications, and medical application, medical instruments, all these applications you are using electronic device. And consumer, all your home appliances and consumer electronics, you are using all the electronic devices. Okay, these are the basic definitions you have to remember before going to study semiconductors, p-n junction diode. Okay, electronics is the study of motion of electrons in a semiconductor. Okay, one electron volts having 1.602 into 10 to the power minus 19 joules. So electronics is the study of motion of electrons in a semiconductor material. Okay, you are using more majorly semiconductor materials, or silicon is more popularly used. Okay, the electronics motion of electrons in the semiconductor material is called as electronics. And what is a device? A device is used to achieve some particular task. Suppose you're having mobile is one device. Similarly, you're having a battery charger, laptop chargers. These are the devices. All any device is used to achieve some particular task. Okay, that is called as devices. Okay, devices are classified into active and passive devices. Active device is nothing but which can act as an energy source. Okay, examples are voltage and current sources which cannot satisfy these three properties, that is linearity, Ohm's law, and homogeneity. They are called as active devices. Examples are diode, transistor, BJT, and passive devices which can satisfy linearity and Ohm's law property. Examples are RLC. Except RLC, remaining all the components are called as active devices. Okay, semiconductors is a material which has the conductivity between insulator and conductor. The resistivity lies between the insulator and conductor, that is in the range of 10 to 10 power 4 ohms per centimeter.